Hi, I'm Richard from Photonics and welcome to video number 8 in our series of LED grow light technology videos. Now today we're going to be looking at design. We're going to be looking at the way Photonics lights are designed and comparing it to the way other lights on the market are designed. Now design is quite often overlooked both by people buying products and people making products. And there are two elements required to produce any good piece of equipment or any good product. It can be something like a complex piece of electronics equipment, or it can be something as simple as a plastic box. You need, first of all, good materials. You're not going to get anywhere without decent quality materials. You cannot make a good product out of crap. The second thing that you need is good design, and it's just as important as good materials. You can take the best materials in the world, use them to make something that's badly designed, and you will wind up with a lousy product. I'm sure we've all had the experience where you've bought something, could be something complex, could be something simple, and it stopped working, and you've traced the problem down to something ridiculous like a little piece of plastic that snapped off inside, and you think, why didn't they make it a little bit more robust? That's bad design. Okay, so first off, let's go to the computer and take a quick look at some conventionally designed LED grow lights and also at a couple of Photonics lights, and we'll take a look at the differences in the design between them. Okay, let's take a look at some average LED grow lights. These are the sort that you can buy online or at your local grow shop. They're all approximately 100 watts, and most of them are inexpensive except for one. Most of them are at or under 100 euros. The other one is much more expensive. Now, if you look at them, they all look pretty similar. They've all got one or two openings on the front, which are basically, you got the circuit boards behind that, and each one of those circuit boards will have a heatsink on the back and then a fan on the top. Now you can see that more clearly in here. You've got two fans for the two modules. You can see the heatsink through the grill at the side. Now, if you're looking at it, maybe you've already spotted what the problem is. Now, these fans are pretty small. One thing I will also mention is that all of these lights are approximately 20 by 30 centimeters, and the total area of the opening on the front, it'd be at one or two, the total area is about 200 square centimeters. They're about 10 by 20 centimeters in these cases. These are 10 by 10, each of them. This one's a little bit bigger. Now, take a look here. These fans must obviously be pretty small. Now, you've got about half of the surface area of the fan is blocked off with this grill. And so it's drawing air in through this grill. It's then passing it over the heatsink, and it's coming out through the slots in the side. Now again, these slots are not particularly big, and they're going to restrict the airflow even more. I would estimate that you're probably only getting about 1/4 or less of the air coming out that you would if the fan was just sitting there in open space. Another thing with having these grills and the restricted airflow is it tends to generate noise. You'll get on top of the sound from the fans, which is going to be pretty high because these fans are tiny, maybe 8 centimeters or less across, and they're going to be spinning really, really fast in order to try and force the air through. So you're going to get a sort of a whistling, roaring noise coming from the airflow as well as the noise from the fan. Now the exception as far as pricing goes is this one. This is a Budmaster. This is 97 watts. It's the same power as the other ones. It's exactly the same size. And the LED area again is about 20 square centimeters. This costs an eye-watering 515 euros, which is almost 2.25 times as expensive as a Photonics 100-watt light. And to give you an idea, in order to grow 1 square meter, 100 by 100 centimeter tent, of 3 foot by 3 foot tent, would require 3 of these at 1,545 euros. So that's really expensive. And as you can see, there's absolutely no difference in the design. If anything, there's probably more restriction on the airflow out the sides than there is on the other ones. Now, as you can imagine, looking at this, the ventilation is not going to be very good, and that is going to cause them to run a lot hotter than they need to. And there's something else. You notice there's nothing else here, which means that the power supplies are inside the light. Now, that's not a good plan. They're going to be pretty warm. And let's compare that to some plant photonics lights. This is the 100-watt equivalent plant photonics light. It's much, much bigger. It's 34 by 36 centimeters, and the entirety of this is light emitting area. The previous lights all had a light emitting area or circuit board area of about 200 centimeters square. This one has almost 1,000 centimeters square, so you've got 5 times as much area for the LEDs to be cooled over than the other ones, which is why you don't need a heat sink. Now, one quick aside about how small differences in design can make a big difference. I noticed that these were considerably louder than the previous generation of lights, even though they used the same fans, and traced it down to these grills. They created a sort of whistling noise, and if this is enough to make quite a difference in noise level, I can imagine what difference the tiny little slots in here would make. So we'll get a little bit more into detail on the plant photonics designs later, but as you can see, the huge difference between them is there is no case. They are a caseless design. We just use this frame around to keep everything together, and these side supports. And these supports, as you could probably make out, do not actually, they're open, so the air is capable of flowing out in all directions. A quick look at the other lights in the series. This is the 150. Again, no case. The only difference between the two of them is this one's even bigger. This is 40 by 45 centimeters. And this is our 50 watt. Again, exactly the same design. Okay, let's go through the points that came up in that section where I compared the plant photonics lights to the other lights. One is the size difference. This box is roughly the same size as those lights, and this piece of foam in the middle is the same size as the size of the circuit boards in there. Now, for comparison, this is a plant photonics 100-watt circuit board. I'm showing you the back at the moment. So you can see there's an enormous difference in size. And I made it like this so that the LEDs were spread out. That provides much more even lighting and will provide you with better penetration than a small concentrated light source. The huge area here is effectively a massive heat sink. It allows for much more effective cooling than having a small circuit board, then some heatsink compound, then a heatsink on top, because the heat doesn't travel very well through the heatsink compounding compared to solid aluminum. And it also allows plenty of space for the LEDs. We have a small section of copper around each LED. Now that is attached to the heatsink of the LED, which is absolutely tiny. It's only about 1.5 to 2 square millimeters. This greatly extends that and allows the heat, because it's copper, it conducts heat very well. It allows the heat to spread out into the surrounding circuit board and is then conducted through to the back. This is not possible when you ram all the LEDs together as they are in the much smaller circuit boards on the other lights. It also provides passive cooling. If your fan fails, the LEDs will not burn out. It will run hotter than normal, but that's about it. With the other lights, if the fan fails, you've got about 10 minutes to notice and unplug it before all the LEDs burn out, which your chances are you're not going to spot it in time, and it's goodbye light. Another advantage of the design, of course, is the lack of a box. Normally things like radiating heat via infrared. If you want to know more about cooling on LED lights, please watch the previous video, number 7, on cooling LED lights. When it's in a box, the infrared radiation is trapped, it heats up the box, which then starts radiating heat back at the circuit board. So it doesn't have any cooling effect whatsoever, it's all reliant on the fan. Now let's talk for a moment about the actual construction of the lights. About 8 months ago, we moved to using 3D printing technology to produce the frames and components for the lights. This is amazing. It's so versatile, and for example, this frame, this is the one for the 100, it's 34 by 36 centimeters, and it only weighs 350 grams. It's extremely strong and very, very light. The reason it's so light and strong is with 3D printing technology, you can actually give it an internal honeycomb structure. Yeah. In order to mount components to it, we use, as you can see here and on the inside, we use brass inserts. These are called reverse head or anti-pull-through inserts. They're actually pushed in from the back and then you screw into them from the front. That makes it virtually impossible for it to break or come loose. Any other type of inserts, you can pull them out. These ones, no, not without literally ripping it through the entire frame. This is one of the supports that you saw in the photos. This is printed out of carbon fiber reinforced polymer. It's extremely strong and rigid, and as you can see, the design in here helps support it. Now, it's not what's called a cantilever design, which is something that's supported here and then has the weight on here. I actually designed it so that it's supported here. These two little tiny screws actually rest on the top of the circuit board and take all the weight off of it. It's basically completely neutral and there's no stress anywhere in this or in the frame, which helps keep it very strong and prevents it from damage in shipping, for example. One of them recently survived being thrown over a 3-meter garden wall by the courier. The resident wasn't in when the courier turned up, and he just heaved it straight over the garden wall, and it actually survived, which, considering it's got these 1 kilo, 2.5 pound power supplies attached to it, is pretty remarkable and attests to the extreme strength of this material. Again, you can see the brass inserts on there. Now, when I designed the light, I had one other goal. I wanted to make it, as I've mentioned, as efficient as possible, as reliable as possible, but I also wanted to make it repairable by the owner, and more importantly, without any tools or knowledge. The reason for that's pretty simple. If you're using a grow light, you've got a plant under it. If you've got a plant under it, you can't afford to lose the grow light for a couple of weeks to several months while it's sent off for repair. Now, everything in here is the best quality possible, but eventually things fail. It doesn't matter how good they are. It might be 5 years, 10 years, whatever down the road. Chances are you will eventually have something go wrong. Now, normally you have to send something back, and this is where buying things that are made in China does become a problem. It doesn't matter whether you buy a light from your local Amazon, eBay for your country, or down at your local grow shop, and it doesn't matter if it's shipped from the company's local warehouse. They don't have a warehouse, they don't have a facility, it's just a fulfillment center that just ships out boxes. If something goes wrong with it, you have to ship it back to China, even if it's in warranty, doesn't matter. That is extremely expensive. It will literally, in most cases, cost you more than the light cost to ship it each way. And the delay can be into several months while it just sits there. And then often they tell you it's your fault, you must have not given enough room for the air to circulate around it, so it overheated, whatever. I know with one company, Platinum Lead, if you look in their 1-star reviews on Amazon, where it turns out they will only take the thing back for repair if you have the original box and packaging, and not very many people keep them that long. So I wanted it easy to repair by the owner. The idea is, if something goes wrong, the owner contacts us, we immediately ship out a replacement part, and the owner can change it in just a matter of minutes. In fact, what we're going to do now is we're going to take one of our 100 watt lights, and I'm going to demonstrate to you how fast and how easy it is to replace a power supply. So let's go do that. Okay, now I'm going to show you how easy it is to change the power supply on one of these lights. This rather brightly colored one is one I'll talk about later. It just shows what you can do with 3D printing. Right, so you undo the power cables, they just unclip, and then it's just these two screws. You can also do this with a hex key, one of the which you can usually pick up at a local shop for about 50 pence or centimes. Make sure you don't lose the screws of the washers. Okay, take that off. Now just take your replacement, screw through. And these plugs will only go in one way, and they lock into place. And that's it. You've now changed your power supply, and it took, what, about 1.5 minutes. Well, now I've explained why I make the lights the way I do. I'm going to explain a couple of things I don't do and why. One of the most common questions I get is, why don't you use secondary optics, lenses? They're not necessary. First of all, you lose about 10% of the light by putting the lens on. It's absorbed by the plastic or reflected at the interface between the LED and the lens, and that's one reason. Another thing is that everyone pretty much is growing inside of a grow tent or a grow cupboard, and they've either got white or mylar walls, and all the light that doesn't land straight on the plant gets reflected back at the plant lower down. And to be honest with you, that tends to give better results anyway than a bright light on top. You get less shadows that way, and the light does actually penetrate better because it's coming in from different angles rather than just shining straight down, in which case the leaves grow out to absorb as much as possible, and then the light doesn't get further down. You may wind up with the top of the plant looking more impressive that way, but you lose out considerably more in development lower down in the plant. Another common question is, why don't you make it compatible with one of these smart devices, Alexa or something like that? Well, to be honest with you, the more complexity you add to anything, the more likely it is to go wrong because there's more to fail. By building a timer, for example, into the light, rather than using a standard outboard timer that you just plugged into the wall or into an extension cord, you run the risk that that timer then fails, like they do, and you've got a light that won't switch on. Even though the light's still functional, the timer isn't, so it doesn't work. Another thing with, for example, Wi-Fi connectivity and Bluetooth connectivity. So say you buy one that's Wi-Fi connected. You download the app for your smartphone, you start up the app, and it goes searching for light, and okay, it found 2 lights or whatever you've got, and fine, great. So you can now control the lights. The reason it can do that is that there's an sort of identity built into the light that says, hey, I'm a Mega Blaster 1000. And if your phone can find that, so for example, could anyone driving by with a Wi-Fi scanner, it would be very, very easy, if you're using it for something illegal, for the police to simply drive by, detect which houses have got lights in them, and knock on the door and ask to see what you're growing. So I don't really think that's a tremendously good plan, and also, again, more complexity, more likely to fail. And that pretty much covers it. I believe in keeping things as simple and functional as possible. There's actually one of the first things you learn in engineering is the KISS principle. It stands for keep it simple. Yeah, and that's something I very much believe in. Well, I hope you found this interesting and learned something. And to be honest with you, looking at the way things are designed is something that you can do every day. Next time before you buy something, just take a good look at it. Think what's likely to get used in it, what's likely to break off in it, and maybe it'll save you some money and save you from making a mistake. Now, I'd like to appeal for some help. I would like to do a video where I strip down a standard LED grow light and take a look at what's inside of it, and then do another one where I upgrade it or, if necessary, repair it. Now, I was going to buy a second-hand light off of eBay. Unfortunately, I found something quite interesting, which kind of reinforces my point about reliability. There are virtually no second-hand LED grow lights on eBay. Now, when you search for LED grow lights and you get something like 17,000 hits, and then you click second-hand and you get just a few, and most of those are marked for spares or repairs, and funnily enough, they actually still want quite a lot of money for them. That kind of goes to show just how unreliable most of these lights are. Think about it. If you've bought an LED grow light, at some point in the future, chances are you're going to want to upgrade it, or you might stop using it and want to sell it. And there should be quite a large number up for sale, but there aren't. Now, if any of you have got an LED grow light that's maybe broken or that you're not using and it's sitting in a cupboard, if you'd like to send it out to me, get in touch with me and I'll give you the address. I'm quite happy to strip it down, repair it, and then ship it back to you after I've done the video. And what I'm planning on doing is, after I've shown what's inside, I'm going to take off the heatsink, replace the heatsink compound with a much higher quality one, probably replace the power supplies, and if there are any leads blown on it, provided they're a type that I can replace easily or that I've got spares for, and most of them use a standard format of lead, so that shouldn't be a problem. I'll repair the circuit board for you as well. So if anyone's got a LED grow light that they'd like repaired and upgraded, let me know and we'll get in touch. So I hope you've liked this video. If you have, please click like, please subscribe, and once again, please leave any feedback and comments. I really appreciate that. It gives me some feedback on these videos. So until next time, good luck and happy growing.